Thinking back to our example from the bar graph, we can build a equation, a function, whatever you want to call it, w equals 71.1 plus 0.15x, where w describes the life expectancy of a woman and x describes an amount of years after 1950. So we can get a prediction, we can get some understanding of the behavior of women's life expectancies after the mid-20th century using this formula here, which is an example of a mathematical model. A mathematical model is just a formula, equation, system of equations, math thing that can be used to describe a real-world behavior. And a word of caution here that a lot of the types of things we're going to see in this class will be in terms of fairly simple mathematical models. Things like this, nice linear things, as I said. In more reasonable situations, what we probably have to do would be a bit more advanced, as dealing with modeling often gets into more complex scenarios with things like differential equations and nonlinear regressions and any number of things that are not quite so nice. And the reason why they're not quite so nice should be pretty evident if you start thinking about what we would do with this model as we took it further and further. That if we wanted to figure out what might happen in, say, the year 2500, well, we're talking about a time that is over 600 years past 1950, which means that this thing is going to balloon a little bit past the realm of likelihood, assuming we don't reach the singularity by then, assuming that Earth is not gone and all of humanity is dead by then. The point is, it's kind of hard to say. We're using a very, very simple thing to describe a very complex scenario, which is to say we're probably using a tool that doesn't quite fit the job. When it comes to modeling, when it comes to using math for these sorts of things, you always have to be careful of where it's getting built from, what data we have to build our model, and what sort of model we built. This is when we built that's very, very simple, which means it's got pretty limited utility. But this is just a very broad idea of taking data, of taking real-world information, and building something that we can use math to get a better sense of how that data should behave. Anyway, that's about all we have here for section 1.2. It's about all we have here for this week. So next week, we're going to be finishing off section 1.3, finishing off chapter 1 with another real-world set of things, talking about how we can use math for problem solving, before moving on into our second chapter to talk about something a little bit more abstractly mathematical. We're going to be looking at what's called set theory. But that's all we've got for this week. I'll see you all in some sense then, unless you start watching my old videos first, in which case you'll see me from way before with worse technology, but it should still work. Anyway, see you all in a little bit.